Well, hello, everyone. The idea is to give a short review on which products can be useful for the Youwind platform from Vortex. So the points of discussion today will be our farm, Sirius, LES, and then we will share a short validation for LES offshore. As an introduction, as many of you may know, Vortex simulates wind resource data for the wind industry through a prestigious atmospheric model, which is the WRF model. The modeled data is able to use at any stage of the project lifecycle and can be simulated at any point around the world. And our products are highly accurate and unique thanks to our pioneering on-demand modeling approach. This is our general portfolio where we can see that Vortex offers solutions for all the different stages for the project. And then let's move to farm. Okay, our farm, it's a wind resource grid at 100 meters resolution, perfect to use when the wind farm area is already selected, but not yet the turbine locations or their class. Let's see now a short video in the next slide.
We find out using trustworthy data, which is the best site to channel your efforts and capital. Vortex offers high-resolution maps that include wind roses, wind speed histograms, and turbulence and extreme wind speed data at an unlimited number of points within the area. How? Through Vortex interface. Online, direct to your desktop. No software download required. Click on New Farm, enter the coordinates, select the resolution, adapt the area, and submit the run. Once the calculation is ready, just click on Run, New Layer, Variable at Type, and then click Request. After just a few minutes, your layer will be ready to visualize and download in ASCII, TIFF, WRG, or KML format.
Eso sí. So, well, the main importance points for the farm is that it's a WRG file that you can directly open with platforms like Youwind. All heights included from 50 meters up to 300 meters, 16 sectors wind direction rows, 100-meter resolution, characteristic turbulence intensity distribution in speed bands, areas up to 4,000 square kilometers in our farm standard, farm large, and farm extra. And then this product can also be calibrated with measurements through our 3D remodeling technology, with measurements at different points, 1 turbine, 2 turbines, even 3 turbines, even different hub heights from turbines. And then the phrase to summarize a little bit the farm, it's that it's a WRG file which characterizes the wind field gradients to compute the mean AEP. Then let's move to Sirius. Okay, Sirius is one of our classic products, hourly and 3-kilometer resolution to use when local measurements are already available and long-term extrapolations are required. I have also a short video that shows Sirius. Maybe I will not keep all the video.
Do you have 1 year of wind measurements but need a long-term view? Vortex offers up to 30 years of hourly time series of modeled wind data.
Up to 30 years time series, model data, wind speed distribution, and different heights up to 100 60 meters. MCP method included in one series through Vortex interface, available worldwide. Yeah, and this is the same, the same process that you can directly download and request the series through the Vortex interface. So the main points for series will be that the resolution is 3 kilometers and hourly. Periods available are 10 years, 20 years, and 30 years. We offer a 6-month free trial through our interface, and the selectable source can be for the NCEP, NASA, and ECMWS, and that's we offer this 6 months for free to check the correlations against your measurements. Variables included wind speed, direction, temperature, and pressure, and then the remodeling, which is the MCP, the Vortex MCP that can be requested directly also from the interface. And to summarize a little bit more, series contains the annual and seasonal variability that modulates such AEP along years and months. And then let's move to the last product, which is the LES. Oh, sorry. LES, it's the most measurements-like set of synthetic wind time series to use to characterize the mean wind and turbulence across the wind farm. Now, I have also a video that shows LES. We have subtitles here.
Discussing what classic turbine would be best for a complex site. One of them says they don't have any measurements for the exact turbine size. Have you ever found yourself in one of these situations? Vortex offers these solutions for these 3 problems. Vortex LES, the synthetic wind time series closest to real-world measurements on the market.
So the main important for this time series called LES is that it's microscale, so 100 meters resolution, any location worldwide. It's 10 minutes also resolution, physically computed 10-minute average records. And then it's the turbulence, it's the wind standard deviation for turbulence intensity calculation. It's included as a variable. And then the period is selectable for 1 full year or long-term, 1 year long-term representative. And to summarize even more, we would say that LES delivers turbulence intensity, which is crucial to compute wakes offshore. Then to show validation done in offshore with product LES, this validation has involved 18 sets of measurements at different offshore locations around the world. The validation focus mainly on 3 variables, which are the most important for wind industry: the wind speed, the wind standard deviation, and turbulence intensity. Here we can see the results for this validation. For wind speed shows a mean absolute error of 3.06% with a slightly negative bias minus 1.31%. And the mean correlations of all sides for 10-minute series, it's 0.84, which is indicative of a very high concordance between the real world measurements and model results. And then you can check for more technical documents and technical and validations, our resources from our website. And then from Vortex side, that will be everything for today. And then let's move with our colleagues from Youwind. Thank you very much.
Thank you, Aina. Edval, when you like.
Sure. Thank you very much, Aina. Very informative presentation, especially around the Vortex products. and especially around the validation and calibration of your products. I think it's it's a quite informative package you have on your website regarding the calibration report and the different products, both for onshore and offshore. So I would encourage all the wind resource specialists to have a look there and see how that sort of stands out in for the various projects that you're working on. So what I'll do now is I'll share my screen here, and I will present slightly information about Youwind and how we use the Vortex products within our platform. So I'm joined here with my colleague Peter. Peter, feel free to jump in whenever or when I forget to say something about our product or the data sets. It's a lot of things to cover over a short amount of time. So there also could be some questions along the way. So as Patricia was mentioning before, please feel free to write any questions you might have, both regarding the Vortex product, but also how we use them into our platform and how you can actually optimize levelized cost of energy. And this we're going to cover in a very short time. A lot of information. So if we can't answer them the questions today, then we will answer them by email, and then feel free to take contact with us after this webinar. So as a brief sort of overview of the combination of the Vortex data with Youwind, it's very sort of we're very happy to have this sort of link from Vortex to the Youwind platform. It's our data sets that we have experience working with for quite many years in different companies, and I would say the Vortex data is somewhat an industry standard for onshore and offshore wind farms. So what we wanted to do in Youwind was to make sure that whenever we're doing early stage screening or layout design, we wanted to make sure that the wind resource and layout specialists and business developers would have ensured the next step in the process. Meaning, it's not enough only to look at a typical wind data set. We need to make sure that the wind data is validated, and whenever we have a measurement, how can we make sure that these measurements are long-term corrected, and sort of to keep the overall process into the layout design and the overall project development. So by using the Vortex products, we basically are assigning where's the best location for my wind farms, which turbine is performing the best, which capacity has the lowest LCOE, and how can I actually produce this bankable yield assessment. And it's a very important factor here that Aina also mentioned about the MCP method from the Vortex platform. You can basically upload a measured data and have that long-term corrected already within your site. So it's a very fast and efficient way to have the data sets. So the Youwind product is essentially we are developing IT solutions. So we are offshore wind experts and have been working in this industry for quite some time. And we have developed these products for other offshore wind experts. So we have developed this very strong IT platform for professionals that want to have this broad base of our experience and our data sets. So we are combining the engineering functions with data sets, with cost estimations, and with the different processes you would need to develop an offshore wind farm. And our basic users are able to generate yield estimates and overall project estimates over different sites in a matter of a few minutes up to hours, when normally this takes for many resources and can take up to a few weeks. That is done today. I'll focus today on Pixel and Pixel Park. So Pixel is our early stage screening tool, where you can basically accelerate your early stage screening with our interactive visualization platform. So essentially, it means that you can draw up a very big polygon wherever you want in the world. We will combine data sets from Vortex, meaning if you have access to the Vortex platform and have purchased some of their products and want to use them directly, you can see and screen directly where is the best place for you to to have the wind farm set up. And the most important thing actually for offshore wind farm development is wind speed. Without that, you don't have anything. It's like when you're trying to cook Spanish paella and you don't have rice. The wind speed is the most important aspect of your offshore wind farm project. So this is one of the things that we are very focused on. So when you have a very big polygon, you want to analyze a very large seabed area, you can simply split the polygons up into very small pixels, as we call it. We will then generate the wind resource. We'll calculate the wind resource at hub height. We'll gather the bathymetry. You can add ground conditions and other human environmental restrictions into your analysis. And then we will calculate the levelized cost of energy and IRR for different locations. And from there, you can also calculate and jump directly into generating a layout and calculating your wake losses, and then continue with your analysis moving forward. So we're talking about LCOE, so levelized cost of energy. So levelized cost of energy is a lifetime cost of your energy project, essentially divided by how much electricity has it generated in the lifetime. So cost and electricity generation is the most important aspects, and therefore the wind speed is obviously very important, but also other losses such as wake losses, such as electrical losses, availabilities, and the overall cost, upfront cost of the capex, and the opex, the operational cost, also plays a very important role when you're looking into the offshore wind farm development. So the key consideration factors are obviously the wind climate, the wind rows, the different wind speed variations, and the turbine spacing. And we'll go through how we generate a layout with an appropriate turbine spacing, so you can minimize the wake losses in the offshore wind farm project. The overall layout is basically dictated by, we are trying to maximize the production, minimizing the construction costs, and you're trying to minimize losses at the same time, and you're obviously trying to meet the planning criteria. So we'll show you how this works inside the platform itself, but basically when you're developing a wind farm, you need to take into account not only the wind speeds and the layout, but all the other different constraints you might have along the way, different pipelines, different cables, neighboring wind farms, Natura 2000 areas, military areas, and so on and so forth. So all these sort of different human environmental constraints you might see, for example, birds and bats corridors. There could be some noise limits, and obviously need to make sure that the grid connection harbors are well in place, and it makes sense for the various stakeholders you have also within the projects, not only the consents team, but also the technical packages for the foundations, electrical, turbine, and the GIS. And then obviously everything needs to be combined into one sort of development area and package where you can seek permitting for this particular wind farm, and communicate them directly and efficiently with the relevant authorities. So from a very basic area like this one here, you're basically able to generate a layout directly within the platform, generate the layout, calculate the wake losses, and see what's the net AP of your particular wind farm. And in the end, what we want to end up with, well, is a visible wind farm where you can see how the turbines are set up, and essentially what's the overall production and the levelized cost of my wind farm. And from there, we start optimizing the different aspects of trying to minimize this cost and keeping the LCOE down as much as possible. So from here, this is a brief introduction to basically what we'll cover today. Then after this brief introduction to the platform and how we use the Vortex products, we'll also jump back and have a short Q&A and covering the different questions you might have along the way. So from here, I'll basically jump into the platform itself. So the platform itself is basically a web-based solution. You can also have a look if you go to the Youwind website directly. You can simply go into the login part here on the right-hand side and go directly inside the platform. When you do that, you simply log in, and the interface looks essentially like this. what we have combined here inside the platform is a very extensive library of turbines, foundations, vessels, the cables, different harbors, onshore and offshore substations, and basically everything you would need when you're thinking about developing an offshore wind farm. If you're thinking about it, constructing the offshore wind farm as Lego blocks, we will have all the different aspects here. And with the process of the platform, you will have the guidebook that will basically enable a very efficient way of constructing the most efficient offshore wind farm part. So we go into, for example, the first item here, which are the turbines, probably the most important thing when you're starting looking into the different aspects. So it's an extensive library of different turbines where you can find access to power curves, thrust curves, and estimation of different prices. But obviously, all these inputs here in the library can be edited directly by the users and used directly inside the project. So this is just a very extensive library, preset library that has been calculated by the Youwind team, and then the users can obviously add their different inputs directly and use them in their projects. Same for foundations. You can choose it between fixed bottom and floating. We'll focus on fixed bottom today for the Danish waters. Most of the areas right there are suitable for either jackets or monopiles. But if you're looking into the different aspects of floating, then you can also go in and choose the different components, choose the mooring system type, for example, and the Youwind product will also calculate the different cost aspects with the mooring footprint, with the mooring line lengths, and with the overall platform calculations. With export cables as well, just to show you a very high level, you can choose between what type of connection you would like to analyze, AC or DC, and also within the different aspects of the platform and how you would sort of add the areas inside the offshore wind farm project. The Youwind platform has the ability to calculate by the engineering functions the export cable lengths and the different losses you have with your settings that you have. So we'll just jump right into it. Feel free to jump in, Peter, if you have a comment.
Yeah, here there was also a question from Bayram online. What about the inter-array cable? So indeed, depending on the density of your wind farm, then also the inter-array cable length is of relevance, of course. And when you make a layout, so we calculate the array cable length and display that, and that's also covering floating wind farms. So you have a dynamic cable that connects the turbine to the seafloor, as well as a static part. So those are all calculations that are included in the Youwind package.
Yeah, thanks for that. It's a good question because also it relates a lot to the different engineering functions that the Youwind platform has. So you can either use these engineering functions that are actually quite well explained, and actually the inputs and the outputs, you can easily go in and see how are they calculated and validated with different reports that we have assembled inside. But for the different aspects as well, the user can also choose to have their own values. So if there is, for example, a foundation team that would like to use a specific weight and a specific technical component of a particular foundation, then the user of the platform can use that value directly and ask the Youwind platform not to calculate the foundation weight, for example. And the same for array cables, export cables, and the different calculations that you have inside the platform. The way the platform works, essentially, you would choose your production capacity, and right now we're just going to choose this 34 turbines of a 15 megawatt, summing up to 510 megawatts. We're going to add this as a production capacity. In the Danish waters and the Danish setup, normally as it is now, I'm not going to talk about the open door tender that is currently under review at the moment. Essentially because we don't know exactly what the outputs will be there, so we're mainly focused on the upcoming tenders probably after 2030 and different potential different updates to these ones. But the way that it works normally in Denmark is the scope is normally not the full scope in terms of offshore platform export cables, but for this presentation to show you also how the export cable calculations and losses and the export capacity works, we'll include that just to visualize that. And the users of the platform can also use this particular project right now here for their analysis. They can duplicate that and do the overall analysis, excluding the OFTO part. By choosing the production capacity right here, we're basically saying what's the choice of overall production capacity for the site. And together with that, we calculate how many turbines you would have. And one of the new things here that we've been working on and analyzing quite in detail is that whenever you want to do an overplanting scenario, you can also add here an export capacity in terms of the choice of the total export capacity at the offshore substations. So this is a way for the users to see if they would like to install one or two or three more turbines at the location, and to see what sort of other export or curtailment losses there might be appropriate as an output for the particular project. And for very high wind sites, this could be interesting for the overall analysis. For now, we'll keep this as the same, so we're not doing a curtailment or an overplanting scenario here. So basically, what I would like to show at the first time here is that you go into area screening, and like with the Pixel Park presentation I showed before, the way that it works, that you enter into a GIS platform that essentially looks like this. The GIS platform is covered with all sorts of open source data coming from our market intelligence. So meaning that whenever you have access to the platform, you have access also to the different areas that are under development or under a possible tender process, or under sort of a pre-development as these ones here in Denmark. But is also added different type of information. For example, the existing wind farms you have, where are they located, and existing wind farm areas where you will have the different aspects, and also the different wind farm points, and the overall sort of everything you would need in terms of the initial GIS screening for your offshore wind farm. So if you would go into the platform right here, and you would like to say, well, here we are in Denmark, and there are different projects you have around here, the Horns Reef 2 or 3. If we're looking at the west side of the country, this new development area here, as an example, and we will not cover anything in terms of a very in terms of an area that has already been developed by a developer. But if you have an area like this, for example, and you want to see where is the best way for me for a very big polygon to start shooting and to start making an offshore wind farm. So the first step would be essentially that you can draw up a very big polygon directly inside here. And I'll just do it very roughly for the sake of time. You can also press it and get the link directly. But the way that it works essentially is that, and the way that the platform is generated is that with this very large polygon, you can essentially split it up into smaller areas. So right now we've done that, we've taken this very big area and we split it onto a small area. And right now what we're doing is that with the access to the Vortex platform, we're gathering the wind speed distribution, and we're calculating the wind speed distribution and adding it as a mean wind speed at hub height. And then what we're gathering here is all the cost functions and all the operational functions you have with this particular wind farm, and we're calculating the levelized cost of energy. So simply by drawing up a very simple polygon like this one, splitting it up, you can get all the most important aspects you have with this particular area, and you can start screening where is the best place for me to start developing the offshore wind farm. For each of these polygons that are drawn up here, you get the wind speed distribution, the LCOE. You also get the bathymetry and the size, and we calculate also the distance to grid and the distance to harbor. And I'll show you how we changed that just now. For each and every polygon, sorry, Peter, jump in here.
Yeah, there's also a question online from Scott Love that the different cost components in the LCOE for each of the pixels below, you will see the table, and also that it's split up will see the different assumptions going into the cost calculation, such as the length of the export cable, etc., and the foundation fabrication costs. But this even goes into more detail if you in the project overview, where you have an overview of the budget and also the assumptions going into that. And for each component, then you can also adjust some of the assumptions that are going into that cost calculation. So you have a lot of freedom to also adjust your cost functions.
Exactly. And all these cost functions can be edited directly and can be adapted by each user. So if you have a tender process where you have updated prices, can be from a turbine manufacturer or from a foundation for foundation package, you can also add that directly. So as you're mentioning here, for each and every area, we calculate the wind speed distribution and the mean wind speed at hub height with the different areas and all the different costs and technical components, including the total project efficiency. And this is extremely important as well when we're looking into the second part here, which is basically where we're going to connect this very big polygon or the different aspects here to an onshore grid. So what we've included here is a worldwide database of onshore grid points. You can simply go in and zoom directly in and see how these wind grid points are. And this is also part of the GIS layers we have. So you can see how these sort of interact. And by simply saying, I would like to use this onshore substation to connect to my offshore wind farm, basically everything recalculates again, and you have the onshore point now right here. And here you can see the changes inside the overall length and distance to shore. And related to that is not only the cost function of your export cables that are linked to this onshore substation, but it's also the export cable losses. And this can be a very important factor actually when you're evaluating a very far offshore project. Same for the, yeah.
And for each of the onshore substations and locations, you also have access to the exact location, and also can edit or add the locations of onshore substations if you have more precise information about that for your particular project. So it was a question from Pedro Piñón.
Exactly. And same for the harbors. You can and we have basically all the major harbors here can be used for offshore wind farm installation and for operation and maintenance. By simply clicking on it, choosing the harbor, everything updates again, and you will have the calculations set up in a way that you have your onshore point, you have your harbors, and you have your overall production related to each and area here. So this is sort of like you would say an early stage screening. So here you would have the different areas. And what about the other part, which is basically what about the environmental impacts? So here we have also different areas of choosing from the GIS layers, what sort of environmental impact risks there are. Are there any Natura 2000 areas? Or are there any pipelines, for example, in the area? There are a lot of pipelines coming from the North Sea into Denmark that we need to take into account. And then what about the different cables of power cables, communication cables as well, that also we need to take into account. So when you're sort of screening the different areas, you can highlight which one are the best areas in terms of LCOE, and which ones are essentially the ones that we need to adapt slightly in terms of taking into account the different human and environmental constraints. You can also go in and see what's the shipping density for the different areas directly here, or you can also evaluate the vessel density and the fishing intensity as well. You can go in and evaluate what sort of fishing intensity historically has there been for this particular area. But just to show how this works in forms of creating a project. So if you already have a pixel here, let's say this is the best LCOE that as you found, you can simply say, I would like to choose this particular pixel here as my development area. And when you do that, you will simply, and you can already generate the initial layout. So the initial layout basically is this tab right here, where you can simply go in and for very easy way, you can choose between what sort of park layout type would you like, what sort of spacing you would like within this wind farm, and what sort of wake model type you would like. And I'll let you, Peter, maybe explain a little bit more how this works in terms of optimization between staggered and a regular grid.
Yeah, also I'd like to take one step back to reply to a question from Eric Simon. And we can also, in the area screening and for selecting the development area, we can add our own layers. You can add your own layers as a user, so you can be more precise about your area definitions, but also about particular constraint areas that might be relevant and that you might have more information of for your particular project. Then for the park layout design, what we do here is we have two different type of configurations that you can have. The very common ones, the staggered grid layout and regular grid layout, and you can set particular spacing settings for those. And then generate automatically a layout. And what we do is we sweep the full range of rotation angles that layout might have, and make sure that it fits in the area that you selected. And after, like Edward is now showing, after you've made your gridded layout, you can also be more free in your layout design and direct the turbines. At that point, we recalculate the wake losses. Wake losses are calculated based on the Enno Jensen model, but also you can use the turbo park model, which is a more advanced model that has been developed by Ørsted and has been validated with the operational data from their wind farms. So that's actually very interesting for because Enno Jensen is an industry standard for calculating wake losses, but turbo park has more realistic wake profiles and is also becoming a more relevant model in industry.
Exactly.
Perhaps this also answers to the question in the beginning of Clement Atwood. How do you ensure that you're getting an optimal solution and not get stuck in local minima when it comes to these layout parameters? For example, we do a full sweep of the rotational angle in order to find the true optimum. Of course, we constrict our parameter space by using grid or staggered layouts, but these are also very sensible and very common layouts to use. And we'll come with more optimization tools soon, actually, on this particular park layout design.
Okay.
Exactly.
Edward and Peter, we have 5 more minutes to finish. Well, we can add it 2 or 3 more. So, but we should start with the Q&A. We already started, but just for you to know that we still have 5 more minutes. Okay.
Sure, no problem. We saved the best for last. Don't worry. So essentially, when you have developed this layout, you can also calculate the blockage effect, but that's something that we can also go into more detail in a separate occasion. I think we would also like to show in more detail on a separate webinar how you would optimize a layout from A to Z using both the Vortex products, but also the different optimization techniques that you have here with the Youwind platform. But just to summarize, also when you have the layout design done, you're calculating the wake loss, you calculate the blockage loss, you get the AEP with wake losses, but you can also get the elevation or the bathymetry per location. So when you have that bathymetry per location already, you can also link that directly to your overall cost estimation. So we calculate everything per position, which is quite important when you're doing this sort of different type of analysis, and you're making sure you're minimizing wake losses, but you also need to take into account different restriction areas and not entering into areas where you might have different soil conditions or bathymetry that are not suitable for your area. So by calculating this, basically using the datasets from Vortex, we can also go in and see directly with a series. We have an example here. So the way that the platforms works, that we are directly linked to the different runs you have from the Vortex platform. So this is just a demo platform I have here, but all the particular runs I have directly linked here, I can use them for my offshore wind projects using the Youwind platform. So this, for example, time series is easily linked to with logging in directly by showing my Vortex runs. I can take in the wind series, and this can be a long-term corrected time series as well. We calculate the park average power. You can calculate per day or per hour, depending on the time series you have. But what we can do also is that we're calculating the difference between the time series AAP statistics and the nominal wind speed that you would have on a 20-year variation that we're using for the other wind farm. So here you can see the different production, the seasonality of the production. You can see the production per year, and you can see how the cash flow changes in between this particular example. And this can also be used when you have on-site measurements of already installed wind farms to see how they are actually performing directly when per year, and how actually your wind resource assessment in the past has been operating. As a final thing here, I would like to show the most sort of interesting thing as well is that one of the things we have inside the platform as well is not only the GIS layers here, we can also upload directly layers. I'll show you how that works, and this is probably a very common thing whenever a developer has an area they would like to see in more detail. You can also go in and you can upload directly the file here. You can say, I would like to upload this development area. I can also draw it up directly and see how that sort of how that is. So I can say I would like to choose a file here directly. I'll say I'll choose this screening here, and when I upload the file, I can get the wind data from Vortex directly. If I upload it, then I see that area comes up directly here. So for this particular area, I can simply hit update, and I will get the same information for this particular area as I did for the other screening. I can also draw up an area directly here, completely freestyle, and get the same information. And from here, you can basically say, I would like to use this area, and I can compare the two. This can be my new development area, and I can start making a layout directly from this area directly here. And from here, for example, we can also upload a layout. So let's say if you have a layout that is coming from an external source that you would like just to evaluate, you would like to see how this particular layout is operating, you upload that layout directly. The Youwind platform calculates with the wind distribution and the different losses how this layout is operating. You can see how exactly it is in terms of the other restrictions you have. Is, for example, a wind farm you have here in the neighboring wind farm, the Anhalt wind farm around, and it's a very easy way to evaluate the different sort of aspects of your offshore wind farm. And from here, one of the last things we've been working on, and very happily to say that whenever you have already this particular area, you can also download this area or any other area you have, and this is essentially the output. So everything is downloadable directly to a KML file where you can see in 3D these different areas of the offshore wind farm, and you can see how the turbines are sort of placed from shore, and use that directly in terms of a permitting process, which is probably for the Wind Europe Fair is going to be the most important one moving forward when we're discussing how we can accelerate offshore wind farms in Northern Europe. This is going to be the most sort of important aspect of this particular part. So that was basically the presentation I had already up to now. Do we have anything else to add here, Peter, before we wrap up?
Yeah.
Yeah, there's a lot of questions online, more than we have time for.
Yeah, unfortunately, but no problem, because we are going to answer all of them, and even the one that are already answered, we are going to summarize them in a document and send to all of you. So don't worry, because all the questions will be answered. Maybe we can have 2 or 3 more minutes for the people who wants to stay and listen some of the answers. Otherwise, we will send it anyway by email. But if you want to answer any of them, Peter, also Pau, there is another for Vortex, the last one. So maybe Peter, you can answer a couple of them, and you, Pau, this one, and the rest of the questions we will send it per email.
Yes, I'd like to add that today we focused on Denmark, and this is, of course, a very well-established offshore wind market. But I would like to highlight that the Youwind app provides information on onshore substations, harbors, and all these kinds of layers that we today showed. And also, of course, the wind resource information from Vortex integrated worldwide. So it showed particular questions online were about Brazil, about Africa. And yes, those are also included when it comes to providing you the information you need to develop your wind park there, and for the future areas worldwide where offshore wind will also be developed, of course.
Yeah, so it's regarding this question about which product is linked. Is that the question, right? Yeah, I think that
Yep.
the blocks, I think it's serious for
No.
sure, and
Serious
I don't know
and
if the
less.
and I think LES is already integrated, right? The blocks is not yet there. Maybe it will be in the near future. Yes, we can keep you posted on from the Youwind information. I mean, all the products should be there. Let's say in the near future. Yes, indeed.
Yeah, maybe yeah, Peter Elbert can give you more information about that.
Yes, for when it comes to the temporal analysis, we support the series and the LES information. When it comes to farms and blocks, we're integrated at the moment, so that you can also get the more detailed spatial variation from those products inside your Youwind analysis.
Okay, perfect. I think if you, Peter or Edvald, want to answer one more question, and then we will finish the webinar.
Yes, perhaps Edvald, there was a question about the financial aspects and how that is how this integrated. Perhaps you can highlight some of the points that we use, because now we focus on LCOE, but there's a lot of other financial performance indicators that you can calculate.
Yeah, sure. We calculate also. So the most important variable for the LCOE is the WACC. So you can also calculate the WACC depending on what sort of debt structure you might have. Same for the internal rate of return. And we calculate also the EBITDA of your project, the normal cash flow, the discount rates, and basically all the sort of important sort of financial information you might need for the analysis, including also the development cost and decommissioning cost, also to mention that we haven't sort of covered.
Okay, then I think we should finish now. And yeah, all the as I said, we will send the recording of the webinar as well as the presentation, the slides, and all the questions, the answered and the not answered yet. And we will also like to invite you to the Copenhagen event next week. We will be in the stand C1, C41, and Youwind will be in the stand S12. And we both are going to co-organize a stand party in the Vortex stand on Wednesday. So yeah, please come visit us, the stand, and we will have time to answer these questions and another questions and have some beers and Iberico ham, why not? Yeah, so see you next week if you are in Copenhagen. And thank you very much for joining us today.
Thank you very much. A pleasure.
Thank you, Patricia. Thank you, Edval.